Hey guys, what's up? Welcome back. So here we are today. We have a fantastic video planned for you, and I know this because it was one of the most watched videos on my original channel and is above and beyond by far the most requested to be re-uploaded here on the new channel. But instead of doing that, we're going to clean up a few of the little mistakes that were in the first video and just make it a little better, and we're just going to make a whole new video. So before I go any further, I am making this video for educational, documentary, and safety purposes only. I do not support, promote, condone, or glorify any dangerous or illegal activities. Be smart about this, guys. This is simply a PID-controlled heated plate system, nothing more, nothing less. So again, this is well within YouTube's community guidelines and does not glorify, promote, condone, or support dangerous or illegal activities. So, the DIY PID heated plate system. We all know that most of the confusion is wiring the whole thing up with the PID. So if you're just here for that, look in the table of contents at the very beginning of this, and this will give you a timestamp to that point. Otherwise, let me go over the components real quick, what they are, what they do, kind of how their job, and also how to search for them, because I'm going to give you Amazon links to everything you see here. We'll have an Amazon link, even specific drill bits and taps if you don't have that stuff already. But if an Amazon link goes out, I want you to understand what this actually is so you can search for it on your own or something along those lines. So, without any further, let's get into the components here. What this consists of mostly is the PID, the relay, the thermocouple, heaters, aluminum plates, a mounting system, and a box to put it all into, as well as some wires, connectors, and M5 screws and some really basic stuff. Again, everything will be linked down below. The main component itself is the PID. This is the brains of the operation. This is what's going to control power to and from the heaters to turn them on and off to then heat the plates to your desired temperature. So this is going to control your temperature and basically, again, be the brains of it. It's going to do that in tandem with two things that are supplied in the kit that I have here. This is an Inkbird 106 ITC 106 VH, and this is basically good for US and European. It does 100 to 250 volts. Very common, very easy to work with. Anyway, it comes in a package with a thermocouple ready wired up. Already has your terminal connectors and a 1/4-20 screw end that we will put into the plate side, as well as it comes with a 40 amp relay. Now you can use the 25 amp relay and save yourself $5, but yeah, it really doesn't matter. Things are so cheap, and either way it's well within it. And this is what's going to actually cut the power according to the PID's signal. Now again, I believe most of the confusion of the build will come from wiring that up, even though it is very simple. We'll go over that. Next down the line is the heaters. Now these are and were the most challenging to obtain in the original build, and that's because they come from China. These are called cartridge heaters. Now that term cartridge heater is what you guys need to know when these links go out of stock or I miss them or this or that. So this specifically is a 100-watt AC cartridge heater. So that means it's going to use AC or alternate current power, which is what you have in your walls, and it's going to use about 100 watts, which is 100 watts of heat in this case. So if you can't find this specific one, they make 120 watt ones, they make 200 watt ones, they make 40 watt ones, they make 80 watt ones. They'll all work, but I'm specifically recommending the 100 watt ones for the ease. And compared to the original build, I believe people are stocking these stateside now, and we will be able to get them much quicker. So anyway, very simple cartridge heater. Cartridge heater is your search term, and that's what's going to get you to the right product. So next we have the plates themselves. Now these are the bronze of the build. The PID was the brain, these are the bronze. Well, I guess technically the press is, but this is what's going to be heating up and actually applying pressure to whatever you have under here. So what these are 3x5 plates. Now in the original one I did a big 6x6 plate build, and you can still do something like this. This build will still work. The plate size is more or less irrelevant at this point. What you're going to be searching for is bar stock aluminum. And again, this is a 3-inch by 1-inch by 5-inch long profile. So when you're searching for aluminum bar stock online, eBay, Amazon, whatever it may be, what you're actually searching for is this width and height. So again, this is 1 inch by 3 inch, and then I have it in a 5-inch long segment here, and I have 2 of these. Now the links I provide you to Amazon are to a supplier named Stoner Metals. He has some really good profiles available, both 3x5 style and bigger 5x5, 6x6 style. Usually in pairs, fantastic shipping. I got these plates, these ones like 2 years ago for like $18 or $14 shipped, and I got my big 6x6 ones for under $30 shipped to my door. So I really support him and his little thing. Anyway, any aluminum bar stock that fits your needs or your profile will work. Now with these plates also comes a little bit of machining. We have to machine some holes in here for the heaters to slide in. We have to put a ground, and we also machine the thermocouple spot right in the center there so we can know the temperature of the plates. Now this is very simple. I'm not here to show you how to drill and tap, but I highly suggest you have a drill press for this. Though it can be done with a hand drill, it's not ideal. And for this build, I'm going to be using 4 heaters, 2 in each plate. And what that's going to do is that's essentially going to guarantee me a very quick heat up time. With the first 6x6 build, it was a little slow, combining 1 heater and massive plates. Now we're putting 2 heaters into smaller plates. I've already tested this. The heat up time is like 2 minutes. It's awesome. Now, to mount this to the press, we've done the same thing as we did in the old build, and this is the floor flange. This is a 1 1/4 inch floor flange for plumbing. It may look a little more familiar to you guys with the wings on the side here. It's a nice circular floor flange. What I did is, because you have to get the 1 1/4 to make it go over most size rams, check, you might be able to get away with a 1, but nonetheless, it's wider than these narrow plates. You see this half would hang off here, which is totally fine. If you don't want to grind this off, you can leave it on there. It's just aesthetics at that point. 2 screws is more than enough. So anyway, I marked it, cut it off so it fits on top of the plate. Really, really nice. 2 screws, M5s to mount them on there. Very simple, very easy, and it goes on very quick. The last part is we have to set the set screws, and this is what actually kind of pinches the ram and holds it still. In the first build, I had a collar that went up, and you can see it was kind of big and bulky. Well, we don't necessarily need this extension, and we drilled right through the collar that's already built in on the floor flange, and it worked fantastic. M5 screws right through there. Again, I used a drill press, but be careful if you're not. M5 pinch in there, very nice. Last of the major components of the build is this project box, and this is in the first build I used a basic junction box from Home Depot. Anything that's going to clean up your build will work. Even if you had a wood box, there's nothing of temperature or anything. As long as your connections are good, you can make a wood box. But this is a ABS plastic project box from Bud Industries. It's very cheap. It was like $7 or $8 shipped. Perfect size, really cleans up the build. And all we had to do was machine a 47mm by 47mm square, so the PID can slide right up in there, just like so. And then 2 holes on the back so we can have power come into this box and then power go out of this box to the plates. That's it, and it closes up very nicely, and in the end will look very good next to your plates. So in the end, you should have a system that looks somewhat like this. Very clean, ready to go and mount onto any press system that you have. For a build like this, I suggest 6 tons to 12 tons. You definitely don't need more than the 12 ton, but if it's a cheap 12 ton press, it's probably really around 10 or 8, so you get the picture. Anyway, 6 to 12 tons for this build, the most you're gonna need. You have bigger plates, you can go 12 to 20. You have smaller plates, you can go less. You get the picture. Lastly, there are some key components here. We have 16, you can get away with 18, but a 16 gauge power cord. 1 or 2 of them works fantastic. One so you can actually just bring in power from the wall very simply to your box. And then another one so you can actually connect the plates from the box that do carry power with a nice jacket. Instead of just running wires, you can run a a jacketed power cord that's a little more protected, so you don't have to go buy any extra sheathing or anything like that. And if you're really in a pinch, you can take one 8-foot power cord and cut it in half, and you have a 4-foot power cord and a 4-foot extension, a little jacketed extension run there. Last couple little components here, we have some I believe these are PG11s. Yes, PG11 gland connector or cable gland connectors. You only need 2 of them. Very simple. And then we're going to need a handful. I believe it's 5 or 6. I use Wago connectors, but you can use a wire nut. You can use any kind of quick connector, wire connector, or you can solder. But anyway, we're going to need about 6 of them. I'm going to recommend the 3 packs. They work very, very well. But if you happen to have like a variety pack with the 5 packs or the 2s, they will work for some, but you're gonna need a lot of more 3s than anything. Without further ado, let's get into the wiring. Let's talk about the schematic, the wiring, and then I'm going to do it all for you outside, right out here in the open, and then we're gonna do it, you're gonna watch me shove it in the box, because it's hard to show you shoving it in the box because there's that technique of shoving it in the box. You gotta make it fit, and that part's not pretty, but we will show you in a nice open space where all the wires go, explain the diagram. Let's get into this. Okay guys, so let's wire this up. Let me talk about the wiring real quick, and then we'll actually wire it up. So what we are looking at here is one of my beautiful diagrams. If you would rather look at the instructional version, it'll get you to the same place. So go ahead, and the instruction version, I believe it's on page 4 of the instructions. It looks like this right here. Or if you forget that one, you can turn your PID sideways, and the 106 VH has it right there on the side, all the terminals that are going to get connected and what they are. But lucky for you guys, you have me, and I have created this beautiful drawing. See, there's a lot of colors. I think you may understand what's actually here, but these wires are what obviously are confusing. So before we go too far, let's actually check out what the colors of these wires represent, what they're doing, and kind of where they come from on this diagram. So we have both AC and DC current going on in this setup. It is mostly AC. There's only a little bit of DC. But here's how they're all represented. The black solid lines, the big black solid lines, will be the AC hot. And that's going to correspond to when we actually do get our power cords, we have a black wire that is our AC hot. Now the next one is in silver because we're on white paper. This is actually going to represent our white wire being our AC neutral. And you can see the third one here, green is ground. Whether we're on DC, AC, doesn't matter. Green or yellow will always be your ground. And they can be the same. After that, we're going to have a little bit of a DC. Like I said, we only have a little DC action, and that's represented by some dotted lines. And we're going to use red and blue so we don't confuse the black. That's AC hot. So dotted red is DC positive, dotted blue, DC negative. And like I said, green ground is always going to be ground. Whether we're grounding a DC connection, an AC connection, it is always ground. And lastly, I have the thermocouple as a blue and red combined little solid line, and that's because right here the thermocouple comes as one piece. It is only at the last 2.5 inches here that it splits off into its positive and negative, and it comes clearly marked as blue and red. So when we get to that, it'll be very, very clear. So that is why the thermocouple itself is a little different, because it's technically DC, but it's generating its own current. So, and as you can see, has everything that is going to go on. We got the PID up here, got the relay here, got the plates here, got thermocouple and some wiring in here. We have cable glands essentially coming into the box here. So this is the full setup. Bam, bam. What the hell's actually going on, right? So it all starts with this. All starts with the PID, and the entire premise of the whole operation is on the back of the PID. And as you can see right here, you got some screw terminals. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You got 11 and 12 up the gut, but those aren't even used, so don't worry about it. But that obviously correlates very nicely to my drawings of the PID. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And as you can see from this overhead view, we have wires coming in and out of it. Well, let's explain that. So all these are is screw terminals. You unscrew them, you put your wire or your connector on there, screw it down, it's tight, good to go. Okay, so we're only going to be using 6 out of those 10, or actually technically 12, but 6 out of the 12 screw terminals on the back of the PID here. We're going to be using numbers 3 and 4 for the thermocouple, 3 for the negative of the thermocouple, 4 for the positive of the thermocouple. We're going to be using terminals 6 and 8, 6 for the negative DC to the relay, and 8 for the positive DC to the relay. And lastly is numbers 9 and 10. 9 we're going to use neutral alternating current, and 10 is going to be the hot from the alternating current. So this 9 and 10, this is your power from the wall. That's the easiest way to realize what AC power is, just the power from the wall. That's cool. Well, how about we wire it all up? So to start off, we got the PID sitting there. We got the relay sitting right here. We have power coming into the box right here, and we have connectors on it ready to go. And then we will deal with the power out in just a second. So just as the diagram goes, let's start with the easy one so you guys kind of get the hang of it. And that's with the thermocouple. See, it's all one wire except for the very end, it breaks out. And just as I told you, we have negative or blue going to terminal 3. We will put that in and screw it down. And then we have positive coming out to terminal 4. So let's get that under the terminal connector there and screw it down secure. So now, just like the drawing shows wires 3 and 4, blue and red, coming off the side, the actual PID has wires 3 and 4, blue and red, coming off the side. Now let's just do the same for the rest of it. The negative DC goes to right underneath. And sometimes it's easier to turn it upside down so the screw terminal falls. Push the wire in. Secure it down. Same for putting a positive DC. And while we're at it, let's just connect these two. You can see on the diagram we have 6 going to terminal 6 of the PID going to terminal 4 or negative of the relay, and 8 going to 3. Let's do that right now. Take your black, go into terminal 4 of the relay, screw it down nice and secure. Take 6, or excuse me, take 8 or your positive from the PID and do it to the positive of the relay. Nice. Now we're really moving along, guys. We got the thermocouple connected and we have the relay connected to the PID. Well, lastly, we're going to need to get power from this wall plug power here. See, the other end of it's at the wall, comes out. Wall plug power here. We need to get power from here to the PID. And we are going to do that with a black and white wire going from its corresponding power to the correct terminals. So for the black wire, which is the hot or the actual power wire here, that is going to go to number 10. Technically, the polarity of this alternating current does not matter because for you guys in Europe, you have 240 volts, and this works for that as well too. But for the sake of sanity here, let's keep it consistent because what we do run through the relay is going to matter. So the neutral AC wire or the white wire is going to run to terminal 9. So now, just like we did, we have a white, a black, and a green. We're going to connect the black from terminal 9 to the black from the wall. Connected and secured. We're going to connect the white from terminal 9 to the white coming in from the wall, power in. Secure. Very nice, very easy. Well, the next step now is we need to get power running out of this box. And we're going to do that You could easily do that by just linking from these open connectors straight over to your power cord jumper coming in. And that's what we're going to do for most of it, except for the hot wire. So before we go any farther, let's just do that. We're going to take the AC going out, or the power out to the plates, and we're going to connect it to the white of the power in directly. Bam. And we are going to connect the grounds together. Now this is green to green, and the only connection. Now the last link between power coming in from the wall and power going out to the plates is this hot line. And this is where the relay comes in. The relay is going to interrupt coming from power in to power out. So we're going to do that by connecting from power in. So power in, right here, we have this terminal. It's going to connect to the relay. And it can connect anywhere. It can connect to 2 or terminal 1. Doesn't matter. That's going to connect to terminal, for now in my drawing, terminal 2. So now we have power coming in, and it goes to the PID, but it also takes a stop here. The hotline takes a stop here at the relay. Now we take the last open terminal here, have the last open terminal on the relay, terminal 1. We're going to put a wire from here make sure it's secure, and this goes to from the relay all the way to power going out to the plates. So now we have a full connection within the relay. We have DC power signaling it when to turn on and off, and we have the actual power break down below. Now guys, we are to the point that all of this would be inside of this box. And at this point, only two things are going to come out. That'll be our 2 cable glands, and one is our power going into it. It's actually not coming out, it's going in, and that's right here. This goes in and stays there. Well, coming out is obviously the AC power, but in addition to that, we are going to buddy it up. You can go ahead and unwrap your thermocouple now, and this is going to run out the back of the plates as well. So from here on, the thermocouple line, once it reaches outside the box, the thermocouple line and the jacketed extension carrying alternating current power to your plates can be looked at as one wire or package of wires. Okay, so this is all inside the box. Like here, we have everything hooked up. We have our power coming in. You can see this nice little stubby just for demonstration. So you see this would be from the wall going in. And like I just talked about, you can consider what's coming out as one set of wires, because out of this cable gland, we have the jacketed extension and the thermocouple coming out one. So they will both run to the plates, and at the other end of them, you have the thermocouple 1/4-20 screw that's ready to go into your plates, and you have the 3 wires of the jacketed extension exposed. Again, black for hot, white for neutral, green for ground. So we can set this off to the side now. Save that for the last connection. And what we're going to move on to is the plates. And you can see a little demonstration here, but I'll just show you. So what we have here are the 4 heater holes. You can see these 4 main holes, 1, 2, 3, 4, so 2 on each plate are the heater holes. That's going to be done with the 21/64 bit, just bored in there, no threads, no nothing. So that's really nice and easy, because the heaters just drop in. If you want to use a little bit of paste, thermal paste or anything, at the very tip to just kind of give it a little suction, it can, but these should be securely in there. Really aren't going to go anywhere once you get your press and plate system mounted up nicely. So we have the top plate, we have the bottom plate. The center hole, which you're looking at here in the top plate, because you only need it on one plate, because we only have one PID system here, is the thermocouple. And the reason we're going to do it on the top plate is because heat rises. So this is going to be the hottest point. If we put the temperature at the hottest point, you know anything that's below it should kind of err on the lower side. So say you set it to say 200 degrees, you know, maybe the bottom plate's not a perfect 200 degrees, but it's like a 190, 195. That's a better error than being hotter than you'd anticipate it for the non-measured plate. So the thermocouple, that's pretty simple as well too. That is literally just a screw right in, and make sure you torque it down just nice and tight. Unless you have a blind tap that bores all the way down, you're not going to get it perfectly flush. So this is where I suggest just a little bit of thermal grease or thermal compound in the bottom of the hole so that there's no air pocket down there and the temperature matching will be as accurate as possible. Then lastly, what we have is the ground, and this is what's going to make sure that if anything were to happen, if any short or anything were to arc or anything, this is going to run back, trip your circuit breaker, and everything's going to be just fine. So what I have is I have 2 green wires here, and I put terminal connectors on them. You don't have to, you can just kind of wrap the wire around the screw, but terminal connectors make it obviously cleaner and a little nicer. These are just getting screwed right into the plates, so I have some M5 screws that we've gotten ready here, and these will get terminal connected right under there. Now this is a step I believe some of you guys may try to skip. Technically the press will work just fine without it, but this is a safety step, so I suggest you do it and do it correctly. So all this is doing again is making sure that if there were any short or anything, this would run back and trip your circuit breaker. So now we need to hook up the wires. So what you'll notice here is there are 2 wires coming out of each heater. One's going to act as a hot and one is going to act as a neutral. Now there's no indication, it does not matter. You could switch these at any point and it's still going to run fine. It's just a resistance heater in there. So we're just going to grab them randomly, and so for the top and bottom plate, I'm going to take 2 wires, just grab 2 wires, give them a little twist together, and we are going to put them inside one terminal. So one terminal, 2 wires going into one terminal of this Wago 3 connector. Now if you have a Wago 5 connector for this multi-heater build here, that'd be ideal, but just double check that both wires are securely in that one Wago terminal. You're good to go. Now take 2 random wires from the top plate, or the bottom plate, excuse me, the other plate, whichever the other plate, and do the same thing and insert that into the next one on that same connector. Again, double check that they're secure by tugging on each wire. So now we have 4 wires connected to this one Wago, 1 from each heater. That leaves 4 wires left out, 4 wires remaining, and we're going to do the same thing but to a separate connector. So start with, I suggest when you're twisting them, twist them from the same plate. That way we can separate them later. So take the 2 that are on the top plate here, twist them together, just a slight twist, and we'll put them both into their single terminal of the Wago. And again, make sure they're secure. And now we will take the remaining wires from the top plate and do the same thing. So we're going to twist it together right here and stick it in the remaining, or in the center. There's actually 2 remaining, excuse me. Again, always check to make sure this is secure because this is AC power. This is where we want to be safe. So if you have the Wago 5s, use them here. Anyway, now we have one more to do. We're going to take these grounds and we're going to connect these 2 grounds together with a Wago 3 as well. Okay, so now what we're looking at here, I'll just kind of get that into your view a little bit more, is we have 3 Wago connectors here, which correspond beautifully to the 3 ends of your jacketed extension. So we've already put the thermocouple into the heater plate. Again, make sure that's nice and tight and has a little bit of thermal grease to help it securely in. Now at this point, we are just going to connect the power out, these 3 terminals, to their corresponding connector. Now, like I just said, the polarity here doesn't necessarily matter because we've connected one of each heater together and one of each heater together here. So whichever one we decide is hot or neutral, that's going to be it. It doesn't necessarily matter. But the obvious one here is green to green ground. So this is what makes the connection. So we have both plates grounded, which will also ground your press and anything else touching to it. We have that grounded, and then the last thing we're going to do is we'll designate this one the neutral here. This group will be the neutral, so we will connect it to the last remaining open Wago. Make sure that's nice and secure. And then our hot, make sure she's twisted up nice, and into the last remaining Wago. So 3 Wagos, 3 wires in our jacketed extension power out. So the last thing we're going to do is we just have to put the flange on here. This is the floor flange that we built already. We've put our M5 set screws right through the side bore holes here. So M5 set screw right there through the side, and then we've already tapped the top of the plates to the corresponding holes right there. As easy as it gets. This is kind of just the last step, formality. If you guys didn't realize this needed to happen, this needs to happen. And voila, that is securely on. Now, let's go mount it to a press so I can show you how it works. Actually, let me get this stubby out of here, get this ready to show you guys. Mount it up, plug it in. We just have to put the flange on here. This is the floor flange that we built already. We've put our M5 set screws right through the side bore holes here. So M5 set screw right there through the side, and then we've already tapped the top of the plates to the corresponding holes right there. As easy as it gets. This is kind of just the last step, formality. If you guys didn't realize this needed to happen, this needs to happen. And voila, that is securely on. Now, let's go mount it to a press so I can show you how it works. Actually, let me get this stubby out of here, get this ready to show you guys. Mount it up, plug it in, and just verify she's working, and we'll work through anything here. We have the plate system sitting here ready to go. We have not plugged it in yet, because before we do, I want to go back into the box. We have the box, we have our power coming in, going to where it needs to go, signals, everything's there. You can secure the relay down with a little bit of thermal epoxy, or you can use some very short screws, or Dremel or grind off the back of the screws if they do go through the project box. But just secure it down so it doesn't move around. And the one key thing we need to do in here is I want to put some electrical tape over these contacts. We have these exposed down here. These are what we want to cover. So we're going to take a strip of electrical tape and we're going to go right over both of these, just to insulate them electrically. So that way anything rattling around in here won't have any issues. So now you can see, just got some electrical tape over the connectors here, or the terminals here and here, for both the AC and the DC. The AC is your main concern there. You don't want this thermocouple sheathing touching that in any way. But the DC side, you also don't want it out over there and there. So we have everything completed, ready to go, ready to plug it in. Let's mount it to the press, and then we'll plug it in, let it start heating up, double check our temperatures, make sure things are good. So as you can see, it's sitting here. This is pretty much everything the press comes with. I mentioned before, anything from 6 to 12 tons will do you right for this build. The more you want to spend on your press to get things like pressure gauges, other things like that, that's up to you. Pneumatic, doesn't matter. But anywhere from 6 to 12 tons with this size plate will get the job done. Bigger plates, more pressure, or towards the upper end of this range. Smaller plates, less pressure towards the lower end of this range. Now, the mounting system here, it's basically, most presses come with these steel blocks. These are great, but the one issue we have with any press and any heated plate system is these get hot, and we don't want the press to get hot. So we need to insulate the plates somehow. Now there's 2 points of contact from the plates to the press, and that's the bottom plate, and it's the top plate to the ram. The bottom plate gets the most contact. It pretty much will sit on whatever you put it. So what I use here is just wood. Most of the time I'm pressing or using this heated plate system under 200 degrees, at most 220, and I haven't gone that hot in a long time. So a piece of wood here, I have a just a little, I don't know what this was at the time, maybe a little more than a quarter, 3/8 piece of plywood or so. And it's obviously gotten a little darker, and be careful, but use some kind of insulating material based on your pressing temperatures, some kind of silicone pad, many of things. Anyway, the bottom plate's, like I said, the biggest contact point. It's also the easiest to insulate. The top plate is a little interesting, and I don't actually have it insulated, and I don't have too much issue with it, but ideally if there was a little silicone pad or something, we could slide down right into here where the ram's going to sit. That would be our ultimate line of insulation. But as long as you get the bottom and you press your material quick, don't leave your press on all day, turn it off, you should be good to go. So without further ado, let's get this press mounted up. All we need to do is we need to align the plates where they need to go. And then we're going to bring the press system down. So now we have the press system down, the ram, the plates, everything's touching, so I can't move the plates. So you don't need to kill pressure, you don't need to squeeze it like you're pressing the biggest thing in the world. You just want the plates flush and to know where they're flat. And at that point, we can start tightening the set screws. And now I use hex or Allen wrench screws for these, just because when you're torquing something against anything, they're a little more secure. But if you just happen to use your Phillips or whatever, it doesn't particularly matter. But we're pinching the ram. That's all we're doing. We're just pinching the ram, and the fact that it's already pressed down in there so nicely. It's nice and secure. Now watch. We're going to release pressure, and the plate will come right up. Bam! So perfecto. I guess it's time to see if all our wiring was correct and plug this baby in. Look at that. Fires right up. Apparently it's 80 degrees in here already. So what you have here on your PID display is you have in green underneath, that's your target temperature. All you need to do is use the up arrows and down arrows to get to the desired temperature, and then press set. And at that point, anytime you unplug or replug in your machine or turn it on or off, it'll go back to that setting. Now you don't need, one of the biggest questions I get asked is, do I need to program it? What settings do I use? If you get the Inkbird, the 106 that I showed you, it comes preset, and most Inkbird PIDs do, and you don't need to mess with any of the settings. If you want to get really complicated with your overshoot and undershoot, and you're one of those professionals, you probably don't even need me for this video if you really need to tweak with your settings. The standard PID settings are really accurate, work very well. So the last thing I want to do is, when we're not using the system or when it's heating up, I want to have the plates resting against each other. That way the thermocouple, well, how it works is this plate will interact and these will reach an equilibrium, and that'll give the thermocouple the most accurate representation of what's going on. Because again, we're only using one PID here. See, the plates are heating up very quickly. That's the whole idea of this double heater per plate system. We have almost instantaneous heat up. It has been less than 2 minutes and we're already at 163, 64, climbing very fastly. So with a system that heats up this quickly, we're going to want to give it just a little bit of time once it does reach temperature to kind of find some equilibrium, get to that true temperature. But nonetheless, look at this baby go, flying. Plates have been sitting here heating up, doing their thing, really just staying at temperature for the last 15 minutes or so. So giving them time to kind of hit an equilibrium there. And you can see I have it at 180.5 degrees here for my desired temperature, and it is like bouncing right up and on that perfectly for what the thermocouple of the PID is saying. And I can tell you by my hands it's pretty hot, but to be even more accurate, I have a secondary thermocouple hooked up here, and this is hooked up in the back right basically where a ground would go. In one of those holes I kind of accidentally put an extra hole in there. So we have the thermocouple back in there, and this is an unjacketed thermocouple, so it's just raw thermocouple inside a hole, and it's reading 185, 186, just under there. And so that's basically, it's about a 5 or 6 degree difference between what I'm seeing here to what's actually going on. And that's pretty good. You know, we're not going to be perfect, and like I said, maybe there's an air pocket. If we could get our taps, our threads down farther, we could get that thermocouple to pinch up against the metal itself. I just didn't quite have the correct tap to do it, I guess. But nonetheless, fairly accurate here, and we can totally work with this. So for me, I know I have about a 5 to 6 degree difference. So if I want to press at 195, I'll set my temperature to 190. But that's really it. We have nothing left to do. Can retire this. And what you're looking at here is a completely functional PID controlled heated plate system. So whatever you want to use it for, go ahead and do that. But thank you guys for following along. Like I said, I know this was one of the most requested videos to be made or re-uploaded or whatever. So I hope this answers all your questions, gets you guys back on track for your builds, for your references, whatever you need this for. That's what it's here for. So thank you guys for supporting me, following the channel. If you're not following the channel, go ahead and give it a follow. Give this video a like. Really appreciate it. Helps it along. We've come back a long way since getting deleted originally, but we will continue to produce fantastic, safe videos over and over and over again. So thank you guys. Peace.